Number 8, figure 4 shows a sketch of the curve C with the equation. This is the curve C and its equation is given 4 plus 12x minus 3x square. The point M is the maximum turning point. Part A1 is write this in this form. Okay, it is 4 plus 12x minus 3x square. This is actually quadratic, write it in this way, 3x square plus 12x plus 4. And you have to complete the square to write it in this form. And for completing the square for a quadratic expression, you should take common from these two. Minus 3 is common. You will left with x square minus 4x. And then plus 4 keep outside. Then half the coefficient of x. Coefficient of x is 4. Half it becomes 2. Take its square, add and subtract that one inside here. Into x square minus 4x plus 2 square minus 2 square and plus 4. So that will be minus 3. This will become a whole square of x, and this is 2. As with x is negative sign, so minus 2 square, and this one you can solve, plus 4. It will be minus 3 into x minus 2 square, and this minus 3 when multiply with this one will become plus 12 plus 4. So you will have minus 3 into x minus 2 square plus 16. So if you rearrange it a little bit, you can write now 16 minus 3 into x minus 2 whole square. So that is the required form we have, where a is equal to 16, where b is equal to minus 3, and c is equal to minus 2. That is what we found in the part A1. Now the second part is hence or otherwise state the coordinate of M. Now clearly you can see here M is the maximum point, and for maximum point, if an equation is written in this form, like a plus b into x plus c whole square in this form, then the turning point is the coordinate of the turning point, or always change the sign of this one, that will be the x coordinate, and then that one. So in this case, we already found that we wrote it in this form. We wrote it in this form already. So if you want to write the coordinate of M, what that will be, change the sign of this one. This is minus 2, it will become 2. And then this constant, that's 16. So 2, 16 are the coordinates for M. Then for part B, the line L1 passes through O and M. In the diagram, you can also see L1 is passing through 2 points. One point is M and the other point is O. And you can see it is going to cross the curve also at points. One of the point is M and the other point is this one, where it crossed the curve C. A line L2 touch C and is parallel to L1. There is another line which touch C and is parallel to L1. Find an equation for L2. Now for finding the equation, what you need, you always need one point and a gradient. Gradient easily we can say, because the condition of the parallel is given there. So if you take the gradient of the line L1, L1 is passing through 2 points. Yes, I will say L1 is passing through M, which is 216, and O, origin, which is 0, 0. So therefore, what will be the gradient of L1? Gradient of L1. That will be y2 minus y1. If you take this x1, y1, and this is x2, y2. So y2 minus y1 over x2 minus x1. So that will be 8. Gradient of L1 is 8. So as L1 and L2 are parallel, I will say as L1 and L2 are parallel. So for two parallel lines, their gradient is same. So therefore, what will be the gradient of the line L2? It will also be 8. Because for two parallel lines, the gradient are equal. So one thing now we got for this one, For L2, we got that its gradient is 8. Now, what else we need? The second thing that we need is now one of the point on this line. Okay. And it is also given that L2 touch C and is parallel to L1. The line L2 definitely touch C. The required line is going to touch the line C, the curve C. So using this condition, we will try to find the coordinate of the point. Okay. So what we have to do here now, let's consider the curve C. This is curve C. The curve C is y is equal to 4 plus 12x minus 3x square. It is y is equal to 4 plus 12x minus 3x square. All right. Now it touched the curve C. One of the condition can be, if I will try to say, as this is a curve, it's said that it's not said that it passes through C. It touch C. Yes. If it just touch, it means it is tangent to C. Because L2 touch C, so it is tangent to C. So you will say, here I will write it as L2 touch C, so therefore L2 is tangent to C. Now if it is tangent to C, we know that for the equation of the tangent, to get the point, what if you do, let's take the derivative of this one, so that it will give you, at that point it will give you the gradient of this one. Because for example, if this is the curve C and this is the point where it touch, so that point we don't know, maybe that point is x1 y1, but we know that its gradient is 8 already. So now using this curve, the gradient of the curve at this point will be the gradient of the line also. So take dy over dx for this one. It will give you 0 plus 12 minus 6x. Now, already we know that for this one, that dy over dx represent the gradient, and gradient for this line already we know is 8. So use this one, 12 minus 6x equal to 8. You will have minus 6x equal to 8 minus 12. And I will get from here minus 6x equal to minus 4. So x will be minus 4 over minus 6, which is 2 over 3. One of the coordinate you got, x1 you got is 2 over 3. This value put here to get the value of y also. So y will be equal to 4 plus 12 into 2 over 3 minus 3 into 2 over 3 square. Okay, let's calculate this one. 4 plus 12 into 2 over 3 minus 3 into 2 over 3 square. So that is 32 over 3. So therefore the point through which the line passes is 2 over 3, 32 over 3. That was the main thing. Again, if you missed that point, gradient we already know for this line. And the question is saying that this is curve C and the line L2 touch the curve. If it touch the curve, it means it is tangent to the curve. If it is tangent to the curve, and the gradient of the tangent to the curve is the gradient of the line also. So gradient of the line we know already. So, and there is another way of finding the gradient by finding dy over dx that gives the gradient. It means dy over dx for the curve is given is equal to 8. So using that one, I found the point x, and this x I put it back in y to get the y point. So the point I found. Now you have gradient. Say this is x1, say this is y1. So equation will be y minus y1 is equal to m into x minus x1. So we will have now y minus y1. What is y1? Y1 here we have is 32 over 3 is equal to m is 8 into x minus x1 is 2 over 3. Just simplify that one. It will become 3 LCM 3y minus 32 equal to 8. 3 LCM for this one, 3x minus 2. And this 3 can cancel from both sides. We will have 3y minus 32 is equal to 8 into 3x minus 2. So 3y minus 32 will be equal to 24x minus 16. Now from here simplify this one. So 3y, take it to the other side, okay? So 24x minus 3y plus 32 minus 16 equal to 0. You will have now 24x minus 3y plus 16 equal to 0. So that is the required equation of line that we want to find